In the logic, if the statement P implies the statement Q, or the statement Q is followed from the statement P, what is the converse of this statement? That means P is followed from Q. P is followed from Q, or Q implies P. This is the converse of the statement. P implies Q implies P is the converse of the statement P implies Q. Now, what is converse of the Thales theorem? Now we can see what Thales theorem says. If a parallel line parallel to one of the side, then parallel line divides the two sides of the triangle in the same ratio. That is what Thales theorem says. That we have proved already. What is the converse of this theorem? Converse of this theorem says that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Or we can say converse of this theorem itself is a Thales theorem. Now I am going to consider converse of Thales theorem here. Converse of Thales theorem. What it says, as I have told, what is the meaning of converse theorem, which I state here. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. You can see given ABC is a triangle and a line DE is parallel to BC, where D and E are points on AB and AC respectively, and AD by DB and AE by EC as in the figure. Now you can see the figure here. Now AD by DB equal to AE by EC. Now what we have to show, DE is parallel to BC. And now you can see, to prove DE is parallel to BC, we need some construction. The construction, draw a line DE dash, DE dash, where E dash is a point on AC as in the figure 2. Now you can see the figure 2 here. DE dash is a point on AC, and we now, with the help of this construction, we are going to prove the theorem, that is DE is parallel to BC. Actually, we assumed that DE dash is parallel to, we are going to assume DE dash is parallel to BC, and further we are going to prove with the help of construction E dash is the same as E. I mean E dash is coinciding with E, and therefore it is going to be parallel. Now you can see the proof. Suppose DE dash is parallel to BC. By the Thales theorem, AD by DB equal to AE dash by E dash C. Call this as 1. But it is given that AD by DB equal to AE by EC. That I will call it as equation 2. And now, therefore, from 1 and 2, we have, what is that? We have AE dash, we have AD by DB, AE dash, by E dash C equal to AE by EC. AE by EC. Call this is third equation. And now you can see, add 1 to both sides of this equation, we get AE dash plus AE dash by E dash C plus 1 is equal to AE by EC plus 1. That is going to be AE dash plus E dash C divided by E dash C is equal to AE plus EC divided by what is that? EC. Now this implies that AC by A dash C equal to AC by EC. Now you can see here, and therefore now you can see, cancel this. What is going to be? Because AC is both on the denominator of both sides, that is 1 by E dash C is equal to 1 by EC, and this implies E dash C equal to EC by reciprocation. Reciprocal of this equation, you will get E dash C is equal to EC. Therefore, E dash is coinciding with E, and hence E dash and E are one and the same. Then we have proved that they are what's that? D dash is a parallel to BC. Therefore, D is parallel to BC. DE is parallel to BC because we assumed that DE dash is parallel to BC, and therefore DE dash DE equal to E dash, and hence DE is parallel to BC only.